An energy conversion is when you change from one form of energy to another. So, as we see with a light bulb, perfect example, you have electrical energy that we get from the outlet in our house or wherever you get your electrical energy, and we transfer that electrical energy through the use of the light bulb into some light energy, right? Because we can see, also referred to as radiant energy, and we also get some heat, some thermal energy, right? Because the light bulb gets hot. But that's not what we want to use the light bulb for. So in this case, that heat energy, it's not useful for us. We don't want heat energy. All we need from a light bulb is the light. So that heat is actually a little bit of wasted energy. And here with the match, you see that what we are doing here is we're releasing the energy held in the chemical bonds of the chemical that coats the end of the match. And as we strike it, it begins to burn. We've started a reaction with the friction of the striking of the match. We have started a reaction that thereby releases all of the potential chemical energy held in that match, and we transfer it to heat and light energy. And there's obviously a little bit of sound in there because you can hear it. All right, so machines are used to convert energy from one form of energy to another. Here we have, this is a gas little heater, and we are converting the potential energy from the chemical bonds in the natural gas, which is obviously chemical energy. We're converting that chemical energy into light energy, because we can see it, right? It's radiating light, and heat energy. Here we have a toaster. Obviously, you plug the toaster into your wall. We convert electrical energy into obviously heat energy, because that's what toasts our bread, and we convert it into some light energy because if you look into a toaster, it's glowing orange, and obviously there's some sound going on because when the toaster pops up, you create some sound. Here are obviously windmills. We are using the energy of motion from air, and we turn it into mechanical energy as the windmill turns, and then we transfer that kind of energy into electrical energy. All right, so let's talk about energy conversions. So there's a balance of energy in the universe, just like there's the same matter that has always been here. The same energy is here because it's not created or destroyed. We only transfer energy from one form to another. Okay, unfortunately, in those transfers, there's always going to be some unwanted energy that we don't need. A lot of this unwanted energy comes from friction. Friction is that oppositional force. When you're trying to move across the floor, fortunately, friction keeps us from falling, but at the same time, friction is opposing us as you strike that match. That friction, that oppositional force, that force that's essentially pushing back or trying to stop your motion, that force is creating some heat. In that case, we might like that heat, but suppose we're trying to move something and that friction creating that heat energy is opposing our motion, causing us to work harder as we try and push things across the floor. Maybe if you try to push a desk across a floor, that oppositional energy is friction, and friction comes with, there's more friction on carpet than there is on a slick surface like the floors in a science lab. So when you try to push a desk across a carpet, there's more friction and you create more heat and lose more energy than if you were to do it on a science lab floor. That would be more smooth and the desk would move more easily. When we have friction, it's an oppositional force. We create some thermal energy. Sometimes it's wanted, sometimes it's not wanted, but it's wasted energy because it causes you to work hard, because that wasted friction energy is not used for work. That's why we call it wasted energy, because it's not used for work. Okay, in all energy conversions, some thermal energy is created. In all energy conversions, some thermal energy is created. In our bodies, as we break down food, that thermal energy keeps our body temperature where it is, as it does in all mammals. But conversions of energy from one form to another. We eat the ice cream, gives us potential energy, and we transfer that energy to motion. The radiant energy from the sun is transferred to chemical energy in plants through the process of photosynthesis, and then we use that chemical energy, the potential chemical energy from the plants or other food, like we showed with the ice cream, and we transfer that to energy of motion. The chemical energy in gasoline was released in the small explosions of a internal combustion engine, so we transfer that to motion in a car. And we transfer electrical energy into tons of different kinds of energy. Thermal energy, sometimes we transfer it to light energy, sometimes we transfer it to kinetic energy, energy of motion. Electrical energy is obviously very helpful. So let's talk about heat. Heat is a specific concept. Heat, we talk about things being hot or cold or getting heat, but the actual scientific term heat only refers to the transfer of thermal energy between two objects. And this always happens, energy always transfers from the high temperature object to the lower temperature object. And the energy transfer, that heat energy transfer, will occur until we reach equilibrium. Nature likes to be in equilibrium. So nature would like for things to be the same temperature. So nature transfers energy from the high temperature object to the low temperature object. So heat is actually that transfer of thermal energy. So if I'm cold, then what's really happening is I am losing some thermal energy to the air around me. So if it's cold outside, then the outside air doesn't have a lot of thermal energy. Nature wants to be in equilibrium, so I begin to transfer some of my thermal energy to the air around me because it's not as warm as I am. And therefore I say I'm cold, but what's really happening is I am losing thermal energy through heat transfer. Alright, and heat transfer can happen through multiple ways. One of those ways is called conduction. That is when you transfer thermal energy from one object to another object through direct contact. As you can see, this is a stovetop. It has got a griddle on it. The thermal energy of the griddle is being transferred to the pancakes and the sausages here through direct touch. You can see that they're touching it, and that is how the thermal energy is being transferred, through direct touch. That is one way. It's called conduction. It is through direct touch. When you touch something and you say it feels hot, what's really happening is heat or thermal energy is being transferred to you through touch, through conduction. So heat is happening, and that heat is the transfer of thermal energy. So something that is a good conductor is going to transfer that energy well. We've obviously talked about metals being good conductors. They transfer that heat energy easily and well. That's why we cook on them, because they transfer the thermal energy from whatever we're using as our heat source or energy source to the food. They transfers it well because it's metal. We use a koozie, which is made of an insulating material. An insulator does not transfer energy well. So that koozie keeps the energy from the air around our soda can from being transferred to the soda can, which contains less thermal energy. So this is stopping heat transfer. That's why we use a koozie, to stop a heat transfer. Some good conductors: a curling iron made of metal, an iron skillet made of metal, a cookie sheet made of metal. All these things are good conductors, are made of metal. Insulators, right? They're made of fabric. They're made of things that don't contain metals, so they're insulators. They're not good conductors. Radiation is another form of energy transfer. It transfers through the air, transfers through space. We transfer radiant energy from the sun. That's how we feel warm. That's what warms up our planet. Okay, here is a solar energy farm taking some of that radiant energy and transferring it into electrical energy. But radiant energy travels through air or space. A toaster works through radiant energy. The bread itself is not touching the coils that heat up in that toaster, but the energy is still transferred to the bread through the air. So it's radiation transfers energy through the air. We call it radiant energy. And convection. Convection is the transfer of thermal energy by the movement of a liquid or a gas. So here we have a liquid. This is a pot. It's on the stove. pot is made of metal. Okay, the flame here is actually touching the pan or pot, and that is conduction. Then the pot itself is touching, you can see this bottom layer here, it's a little darker blue. That is the area of the water that is in contact with the pot that is receiving some energy through conduction. However, as that water heats up, its particles are moving faster, they spread out, they are less dense. Because they're moving faster, they spread out, they are less dense. So the less dense, warmer water particles rise because less dense objects float. Those warmer objects rise, the cooler objects sink, and then they heat up, and then they rise. And then the other ones have cooled off a little bit, so they sink. So it creates what is called a convection current. So convection is as things warm up, they rise. The things that are on top are cooler, so they fall. And then the process continually repeats, creating convection. It's the movement of a liquid or gas because of its gaining of thermal energy. And then it transfers that thermal energy by moving around. Gets hot, rises. The cooler stuff falls, and then it gets hot, and then it rises, and once again it's a continual process. So just the water here is heated by conduction, but all this water here is heated by these convection currents that you see continually happening as it gets hot and rises, then it cools off a little bit and falls and gets hot again, and it continues through the cycle. It's also the way the air in our atmosphere is heated. The sun heats the air, the earth, and it creates a convection current. Solar energy heats the Earth's surface. The air closest to the Earth's surface, in contact with the Earth's surface, gains some of that thermal energy. It rises. As it gets up here, it cools off a little bit, and then it falls. And this is a convection current in a gas. So we saw it in a liquid before, and this is a convection current in a gas. So the three types of energy transfer, the way to transfer thermal energy: conduction through touch, right here, through touch, right? The Earth's surface is touching the air right here at the Earth's surface, causing conduction. Through radiation, which is how the sun heats the Earth's surface. And then both of those combine to create this convection current, this heating by convection as the particles move around and that thermal energy is transferred. Conduction here as the Earth's surface touches the air. Radiation as the sun's energy reaches the Earth's surface. And then we create the convection because the warm air that is heated by the surface rises. As it gets up here, it cools off and then falls. It gets heated up again and creates a convection current. And that is all.